Hello. The climate on Earth can actually be altered by changes in the Earth's orbit, and this is done on a fairly regular in a fairly regular, understood way. In three main ways, really. The first one is, as you can see on this diagram here, the eccentricity. The Earth's orbit is normally elliptical. It's very nearly circular. Not exactly. It's actually elliptical. But as you can see in this diagram here, it does actually vary quite a bit. You can see the sort of, I can call it the inner ellipse here. That's quite different. And this will obviously affect climate. And this is this particular change has a period of 100,000 years. The second effect is the obliquity. Now what it's trying to show here is that obviously, as you probably know, the Earth is already inclined at an angle anyway. It's currently 23.5 degrees. But what this diagram is telling us is that this inclination will tend to vary between 22.1 degrees and 24.5 degrees. So currently it's about 23.5, roughly speaking, about halfway. This particular cycle will vary on a period of 41,000 years. The third one, and possibly better known, is the precession. Again, if you can look at this diagram here, this is very similar. Well, it's probably easier to understand in the sense that you probably mostly experienced something of this nature anyway, by virtue of a spinning top, or more generally through a spinning gyroscope. I mean, you've probably seen this sometime or other, that a gyroscope inclined at this angle, or equally a top, will actually precess in a circle. It'll keep the same inclination, but it'll precess around. If this was the Earth, and if you were to look at along the north axis, then that would eventually point to Polaris, the North Star. But you can see that as it circles around, the North Star is going to change from Polaris. It's going to go around. The north point is going to go around in a circle. It's going to go through Vega, and it's going to describe a circle on the sky. Coming back to Polaris eventually, with a period of 26,000 years. Now this diagram here is supposed to show the situation of the Earth's orbit as it is now, in a highly exaggerated way, exaggerated for clarity. Now we can just ignore that for the moment and consider the inclination of the Earth. I mean, the seasons of the Earth are determined by its inclination. As we just said, it's now currently about 23.5. Now, if there was no atmosphere on the Earth, if it was just down to the orbital considerations, then up here in Britain, we would expect to have our warmest period in June, because that's when the sun is at its highest. Up at the Tropic of Cancer. So purely from astronomical considerations, that's when you would expect the weather here to be hottest. But as you know, it's normally hottest in August due to the effects of the atmosphere. So if we go back to this diagram again, if I was to consider it purely in terms of just ignoring the atmosphere, you would expect the situation. Well, let me explain this first. Up the left, that shows us up in our summer. That's presumably representing June, the aphelion. And that's obviously when we're most furthest away from the sun. Up at the right, that would be the summer, corresponding to the summer, say somewhere in Australia, and that's when they would be closest to the sun. I mean, if there was no atmosphere, you would expect, all other things being equal, for the summer in Australia to be hotter because it's closest to the sun, but at the same time shorter, because when the Earth is down there, or when I say down there, when it's over to the right, then the Earth is moving faster along its orbit. As I say, whether that's true or not is affected a bit by the atmosphere. But if I can show you this amended picture now, down at the bottom here, it's shown as what's going to happen in half a cycle's time, namely 13,000 years, where everything is reversed. Now our summer is down on the right hand side, and Australia's summer, if you like, is over on the left hand side, and everything is reverse to what I just said before. So yeah, those are the three main effects. Anyway, I'm not really going to expect to say too much about the ins and outs of man-made climate warming, but I'm just pointing out that the climate can be affected by purely astronomical reasoning or astronomical reasons, but these are on a definite cycle. I mean, there are you hear these climate change deniers trying to point to other astronomical reasons. For example, they might say that the sun is hotter now than it was before, and that's to blame. But in fact, there are sensors and satellites around the sun, and currently the sun appears to be emitting less radiation than normal. So that would be a bogus argument to blame the sun for the current global warming. Anyway, cheers for now.